Hi students, welcome back to Wisdom Academy YouTube channel. Today we are going to see the NCERT textbook questions of electric potential and capacitance. So after completing the second unit of physics, today we are going to see all the textbook questions. Let us start. The first question is that two charges 5 into 10 power minus 8 coulomb and minus 10 to the power minus 8 coulomb are located 16 centimeter apart. At what point on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. So they have given two charges. One is 5 into 10 power minus 8 and second is minus 10 to the power minus 8. So Q1 is 5 into 10 to the power minus 8, whereas Q2 is minus 3 into 10 to the power minus 8 coulombs, and they have told that distance between them is 16 centimeter. So they are 16 centimeter apart. So I will write like this, 0.16 meter. So what they are asking you to find? They are asking you to find at what point on the line joining the two charges the electric potential is 0. So the line joins two charges, at what point the electric potential is 0? This is the question. So what is the distance? Let the distance be x, right? So if the distance is x from the left side or from the first charge, then the remaining distance will be 0.16 minus x. We know the formula of potential, it is kq by r. So we they are saying potential at 0, Vp. So Vp, for Vp to be 0, I can write k into q, that is 5 into 10 power minus 8 by r, that is x, plus k into minus 3 into 10 power minus 8 by this r, that is 0.16 minus x, which should be equal to 0. I equate both, I get k 5 into 10 power minus 8 by x. I will take that this side, it will become k 3 into 10 power minus 8 by 0.16 minus x. K gets cancelled and this 2 also gets cancelled. So I will get 0.16 minus x into 5 is equal to 3x. So when I solve this, I will get 0.16 into 5 minus 5x is equal to 3x. So 8x is equal to 0.16 into 5 and x will be equal to 0.16 into 5 by 8. So 0.02, that is equal to 0.1 meter, that is equal to 10 centimeter. So what we found? We found that 10 centimeter from the left charge or from the Q1, the potential at this point is 0. But it is not the end, because there is also a possibility that the point may lie somewhere in this line, in the axial line. So let us take the second case. Second case is the case where I am assuming the point to be somewhere here, the potential as 0. So from this charge, let the distance be x, this is 0.16 meter, but this will become x minus 0.16. I will use the same formula and I will get, for Vp is equal to 0 at this point, I will get k into the q. Q was 5 into 10 power minus 8 by r is x now, plus k into minus 3 into 10 power minus 8 by x minus 0.16, that should be equal to 0. So when you solve this, you will get k into 5 into 10 power minus 8 by x is equal to k into 3 into 10 power minus 8 by x minus 0.16. This 2 gets cancelled, this 2 gets cancelled, and I get 5x minus 0.16 into 5 is equal to 3x. This comes this side, so it becomes 2x is equal to 0.16 into 5 and x will be equal to 0.16 into 5 by 2. So to 0.8. So it will become 0.08. So 0.4 meter, and that is equal to 40 centimeter. So what we came to know, from the left charge it is 40 centimeters away. So both these answers are correct. This answer is for the point if it is taken away from the arrangement, and this is the point if it is taken between the arrangement. Second question is, a regular hexagon of side 10 centimeter has a charge of 5 microcoulomb at each of its vertices. Calculate the potential at the center of the hexagon. So they have taken a regular hexagon. We know that regular hexagon will have 6 sides and all will be equal, and the size is given as 0.1 meter, and at each of its vertices there is a charge kept of 5 microcoulomb. They are asking you what is the potential at the center. Let the center be O. So we know that in regular hexagon, all these triangles will be equilateral triangles. So this will be 0.1, 0.1 and so on. All these lines will be 0.1. So what will be the potential at this point? Due to this charge, it will be kq by r, kq by r, kq by r. How many times kq by r? 6 times. So V at O will be equal to 6 into kq by r. So what is k? 9 to the power 9. What is q? 5 into 10 to the power minus 6. And what is r? 0.1. When you solve this, 3270 into 10 to the power minus 4 volt. This is the answer of V at O. Let us see the next question. The next question is two charge of plus 2 microcoulomb and minus 2 microcoulomb are placed at point A and B 6 centimeter apart. So there are two charges plus 2 microcoulomb. This is the third question. So plus 2 microcoulomb is there, point A, and minus 2 microcoulomb is there at point B, and they are placed 6 centimeters apart. They are placed 6 centimeter apart. Then they are asking you identify an equipotential surface of the system. So see, how will the electric field be? Electric field will be from positive towards negative. So I mean the electric field will be like this, and what will be the equipotential surface? At any point, if you see, it will be a plate like this, and they are asking you to find what is the direction of electric field at every point on the surface. On this surface, what will be the direction of electric field? It will be exactly perpendicular, which will be from negative towards positive. We know very well that always electric field is perpendicular to the equipotential surface. Exactly that concept I have used in this question. Let us see question number 4. So question number 4 says that a spherical capacitor of radius 12 centimeter has a charge of 1.6 10 to the power minus 7 coulomb distributed uniformly on its surface. What is the electric field? First thing is inside this sphere, second just outside this sphere at a point 18 centimeter from the center of the sphere. So this question they are asking you to find the electric field. About the electric field, already we have discussed in the previous chapter. What is the electric field? It is K into Q by R square. So in this question they have given a spherical capacitor which is having a radius of 12 centimeter. So spherical conductor is there which is having the radius is 12 centimeter, it is 0.12 meter, and it has a charge of 1.6 10 to the power minus 7 coulomb all over its surface. So it has charge distributed, and the value of this charge is 1.6 into 10 to the power minus 7 coulomb if I am right. Yes. What is the electric field inside this sphere, just outside this sphere, and at a point 18 centimeter. So one thing, you know that inside this sphere, what will be the charge? You have to use Gauss law, and you have to use Gaussian surface. So if you make Gaussian surface here, there is no charge enclosed. So the first sub case, that is inside the sphere, what will be the electric field? It will be 0. Reason is no charge is enclosed. No charge is enclosed by Gaussian surface. Then what is the second part? It is present just outside the sphere. So just outside the sphere, what will be the radius? 0.12 meter. So what will be the electric field? It will be K Q by R square. K is 9 to the power 9, and what is Q? Q is 1.6 into 10 to the power minus 7, and what is R? R is 0.12 square. So when you solve this, you will get this much Newton per coulomb as the electric field at just on the surface. And third thing what they have asked you to find the electric field at 18 centimeter away from the center. So from center 18 centimeter away. So that will be equal to again KQ by R square, and instead of 0.12 I will use 0.18. So 9 to the power 9 into 1.6 to the power minus 7 divided by 0.18 square. So when you solve, that much Newton per coulomb will be the electric field present 18 centimeter away from the center of the sphere. Let us see next question. Next question is a parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plate is reduced by half and the space between them is filled by a substance of dielectric constant K is equal to 6. So they have told there is a parallel plate capacitor, and for this parallel plate capacitor they have told that the capacitance value is 8 picofarad. I know that, I hope you know that 1 picofarad is 10 to the power minus 12 farad. This is 8 into 10 to the power minus 12 farad. Now what they are telling that the distance between them is reduced by half, and there is dielectric constant, dielectric substance kept between them. So suppose this was the distance between them, then it becomes half, and it is filled with some dielectric inside. So now this, if suppose this was D, this became D by 2, and some dielectric material of dielectric constant 6, if I am right. Yeah, it is 6. They are asking what will be the new capacitance. So we know that capacitance formula is epsilon naught A by D. This is epsilon naught A by D. And what will be the capacitance here if dielectric is introduced? We know it is epsilon naught K into A by D. D dash, because area is not changing, so I will write D dash. And what they have given? They have given the value of K. Epsilon naught is 8.85. Okay, no enough using this itself. There is one shortcut to solve this. So what I can do? D dash I can write D by 2 because it reduced by half. So I will write epsilon naught K A by D, and 2 will go above. So I can write this to be K into 2 times epsilon naught A by D, and we know epsilon naught A by D is 8. So I can write C dash is equal to, what is K? 6 into 2 into this value, that is 8 picofarad. So 6 to the 12, 12 8 is a 96 picofarad. So 96 picofarad will be the capacitance if the distance between them is reduced by half and dielectric of constant 6 is kept between them. Let us see the next question. 3 capacitors, each of capacitors 9 picofarad, are connected in series. What is the total capacitance of the combination? Very simple question. Everything is having 9 picofarad capacitance. So there are 3 capacitance and they are connected in series like this, and everything is having 9 picofarad, 9 picofarad and 9 picofarad. They are asking you to find what is the net capacitance. We know that for series 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3, and then 1 by Cs will be equal to 1 by 9 plus 1 by 9 plus 1 by 9, and that will become as 3 by 9, that will become again 1 by 3. So Cs will be equal to 3 picofarad. What else they have asked you? They have asked you what is the potential difference across each capacitor when the combination is connected to 120 volt supply. For this combination, if they connect to a supply of 120 volt, then they are asking what is the potential drop across each capacitor. So we know that if we connect it to a potential difference, then potential drop across each thing will get divided based upon what is the capacitance. Luckily here we have same capacitance, 9, 9 and 9. So what is the potential drop across this and across this and across this? These 3 will be same. So this one and this one, that will be same, that is 120 by 3. So V across each capacitor will become equal to 120 by 3, that is equal to 40 volt. Let us see the next question. Next question is 3 capacitors of capacitance 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel, 2, 3 and 4. So I am having something like this, 2 picofarad, 3 picofarad and 4 picofarad. 2, 3 and 4 picofarad is connected in parallel. Then they are asking you to find what is the equivalent capacitance. So what is the total capacitance? We know that for parallel, C parallel is equal to C1 plus C2 plus C3. So 2 plus 3 plus 4, and that is equal to 9 picofarad. So 9 picofarad will be the net capacitance of all these 3. And then what is being asked? Determine the charge on each capacitor if the combination is connected to 100 volt supply. Now this combination is connected to a supply of 100 volt. So suppose a 100 volt supply is connected to this, then they are asking what is the charge across each. So we know that Q is equal to CV. So for this Q1 will be equal to C1 into V, for this Q2 will be equal to C2 into V, and for this Q3 will be equal to C3 into V. Because we know that V is constant, V will be same for all these 3. So what will be Q1? Q1 will be equal to C1. What is C1? 2 into what is V? V is given 100. So that will be equal to 200 picocoulomb, because it is picofarad. So Q2 will be equal to 3 into 100, that is 300 picocoulomb, and Q3 will be equal to 4 into 100, that is equal to 400 picocoulomb. Let us see the next question. The question is, in a parallel plate capacitor with air between the plate, each plate has an area of 6 × -3 meter square. So the question says that there is a parallel plate capacitor and the area of each plate. I hope you can, you are imagining how this thing is in reality. It is something like this. It is not like a two-dimensional diagram. It is like plate is there and another one plate is there. Like this it is parallel plate capacitor. So area of this plate is given. How much area of the plate is given? 6. It is 6 into minus 3 meters square. And they have given the distance between them. This distance is given. Distance is given as 3 millimeter. That is equal to 3 into 10 power minus 3 meter. Then they are asking you to find the value of capacitance. So we know that capacitance for a parallel plate capacitor is epsilon naught A by D. That question. So epsilon value is 8.85 and 10 to the power minus 12 into area of the plate is given as 6 10 to the power minus 3 and D is given as 3 into 10 to the power minus 3. These two gets cancelled. This becomes 2 times. When you solve, you will get 17.7 into 10 to the power minus 12 farad. I can write approximately equal to 18 picofarad. So 18 picofarad is the capacitance. In the same question, they are asking you to find if the capacitor is connected to 100 volt supply, what is the charge on each plate? So now this capacitor, if it is connected to a 100 volt supply, then what is the charge coming on each plate? So we know that charge coming on each plate can be found by Q is equal to C into V. So what is C? C is given as 18 picofarad and what is V? V is 100. What is the charge? 1800 picocoulomb, right? So that is equal to, I can write 1800 into 10 power minus 12 coulombs. Let us see the next question, question number 9. Next question, explain what would happen if the capacitor given in the previous question, a 3 mm thick mica sheet of dielectric constant 6 was inserted between the plates while the voltage supply remains connected, and second part is after the supply was disconnected. So first what they are asking, that when the supply remains connected and in between the plates, if I am inserting another dielectric material, and that is mica. So I am putting here dielectric material, that is mica. So this mica I am putting, and this has a dielectric constant of 6 they have given, if I am right. Is it 6? K is equal to 6, yeah. They are asking what will happen if the voltage supply remains connected. They are asking you to find how will the capacitance change and how will the charge change. So what will happen to the capacitance? So we know that capacitance is equal to K, I mean epsilon naught K A by D. So D remains same, epsilon naught A remains same, only K times will increase, or C dash. So I can write C dash will become equal to this K into epsilon naught A by D is what, this thing. So this C. So what is K? K is given as 6. And what is C? We have found 18 picofarad. So if you multiply, it will become 108 picofarad. So 108 picofarad will be the capacitance of this condition. And what will be the charge now? Will charge remain same? No, because C has changed, Q will also change. So Q is equal to C into V. What is C? C is given as, so we have found it is 108 picofarad and V is 100. So it will be 10800 picocoulomb. That I can write it as 10800 10 to the power minus 12 coulomb. Second part is after the supply was disconnected. So when the supply gets disconnected, then let us see what happens to the potential itself, because suppose now what happens in this case, the supply is disconnected, this supply is removed. So when the supply is removed, there is no potential applied externally. What will be the new potential on this? So when there was no V, then definitely the charge will also remain same, it will not become this charge. So what charge was initial there? Initially the charge was 1800 in 10 power minus 12 coulomb. And what is the C value? C value after putting the dielectric, it is 108 picofarad. So what will be the V? V will be equal to, we know that Q is equal to C into V. So V will be equal to Q by C. So what is Q? Q is 1800 in 10 power minus 12 and divided by C dash 108 picofarad 10 power minus 12. So when you solve this, you will get 16.67. So you will get the potential difference as 16.67 volts. Let us see question number 10. A 12 picofarad capacitor is connected to a 50 volt battery. How much electrostatic energy is stored in the capacitor? So, they are given the capacitance is 12 picofarad and they have given the voltage of battery as 50 volt. They are asking you to find what is the energy stored in the capacitor. We know that formula based question, U is equal to half CV square. So, half, what is C? 12 into 10 power minus 12, and what is V? V is 50 square. When you put all these things into picture, you will get the answer. This much joules will be the energy stored in the capacitor. Go to question number 11. So, question number 11 is something like this. A 600 picofarad capacitor is charged by a 200 volt supply. So, one 600 picofarad capacitor is there, charged by a supply of 200 volts. Then what they are saying? They are saying that it is then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. So, after charging, it is taken out and kept with another capacitor of capacitance again 600 picofarad itself. Fine. How much energy is lost in the process? Okay, so they are asking you to find U lost. This is a question from redistribution of charges and energy lost. So, I have made one video previous video where I have talked about this thing, how much energy is lost in a capacitor. So, first what we will do, we will try to find what is the common potential. So, common potential, that is V, will be equal to C1 V1 plus C2 V2 by C1 plus C2. So, what is C1? C1 is 600. What is V1? V1 is 200. What is C2? C2 is again 600. What is V2? V2 is 0. I think they are not giving anything. Yeah, 0. And what is C1 by C2? C1 by C2 will be 600 plus 600. So, this term is 0. This becomes 600 into 200 divided by 1200. So, this becomes 6 times and this becomes 100. So, what is the common potential? It is 100 volt, isn't it? Then what you have to find? You will find initial energy, you will find final energy, and then you will find Ui minus Uf to get the value of U lost. So, what will be the initial energy? Initial energy will be equal to half C1 V1 square plus half C2 V2 square. And what will be the final energy? Half C1 plus C2 into V square, because you know that in the final condition I have put the common potential. So, if I put the values here, half into what is C1? C1 is 600. What is V1? V1 is 200 square, and plus half 600, and this is 0 square. So, this term will become 0. Same way here, half, if you add both, it will become 1200, and V is 100 we have found square. So, when you solve these two and subtract, that much joule will be the energy lost. Please do it by yourself. So, what we have seen today, we have seen all the numericals of NCERT from electrostatic potential and capacitance. You may be wondering about additional questions. I will make additional questions a separate video where I will be talking about all the additional questions. So, in this chapter, you have learnt about all the potential related questions, you have learnt about capacitance, and you have learnt about energy loss in the capacitor, you have learned about redistribution of charges. So, please make sure that you have seen all the videos, done all the questions, and one more thing I will want to repeat, that these questions what we are doing is definitely not enough for the school examination. You have to practice from various reference books, and then only you will get come on the subject. So, with this I will request you, please subscribe the channel, like the video and share with your friends. Thank you.